Welcome everyone. So finally we're at the final part of this chapter, which is inequalities. Without further ado, let's go to the first example. So in the inequalities, you're not going to be asked to write solution set. Instead, we will draw the graph of its solution set because it's more efficient that way in this type of problem. Let me show you what I mean. So here we have x more than 10. So it can be any value greater than 10, such as 11, 12, or even 1 million, or even 2 million. But it can also be like a little bit slightly greater than 10, like 10.05 or 10.00001. Nah, that's why it's impossible to like write all the solutions one by one. It is more efficient to draw the graph. How do we draw? Now, how do we draw it on the number line? So start with the number line, because number line can go infinitely positive or infinitely negative. We put arrow there, and then we put a 10. X greater than 10 does not include the 10. That's why we put like a blank circle, open circle here, and we can color. Yeah, those are the value greater than 10. Now, let's start again with the next one. X is less than or equal to 3. Don't forget the arrow and then put 3. This time, 3 is included in the set. That's why I draw a closed circle. A black, not black, closed circle, full circle. Now let's draw. So any value less than 3. So to graph the solution set of these inequalities, let's simplify it so we can draw the graph later. How do we simplify? We can use add and subtract. So here I add 2 to get rid of the negative 2. Thus I get 4x 10 plus 2 for x less than 12. Now, we can still simplify this by dividing by 4. And I'll get x less than 3. So easy peasy. It's simpler to draw rather than the first part, right? 3 without equal sign, so open circle, and let's draw. You can make a shadow or highlight if it's easier. So for addition and subtraction, there's really nothing to worry about there. Just add and subtract like you would in equalities. However, in multiplication and division, you have to be careful when dealing with negative number. So when you multiply or divide with negative number, you change the sign. For example, this, I have negative 5x greater than 20. To get x, I will need to divide or multiply. I'll multiply this time with negative 1 over 5. Multiply with negative 1 over 5. See, I'm multiplying with negative number here. So I got x and this one negative 4. When you multiply with negative number, the sign change. So from greater than, it became less than. Arrow, arrow, negative 4, and less than. And, okay, I forgot the open circle because the negative 4 is not included. For this next example, you might encounter inequalities like this. You have double inequalities. Don't worry, to solve this, it's really easy. You can like solve right away for all the 3 members at the same time, or you can break it down. So later for the second strategy, I'm going to write it there. So here, I will get rid of 4. That means plus 4 everywhere. So I get 10, 3x, 19. Now, to get x, divide by 3. Everything is divided by 3. Remember, keep them in balance. So I got x, 10 over 3, and 19 over 3. Let's draw them in a number line. We have 10 over 3 here, The 10 over 3 is not included. 19 over 3 included. And x is between them. Or you can also break it down if you want, like do it twice. First, the 3x minus 4 greater than 6, and then 3x minus 4 less than or equal to 15. This one, 10x greater than 10 over 3. This one, x less than or equal to 19 over 3. It should be greater than 10 over 3, but then less than 19 over 3. So the next one here, we're going to see the difference in solving inequalities with absolute value. The symbol here is very important. You need to pay careful attention to that. So we've talked about how absolute value actually means or actually talks about distance. So x absolute less than 5 means the distance to the origin point is closer than 5. So in a number line, our origin point is 0, and the distance of x needs to be closer than 5. All the value needs to be less than 5. So I have 5 here, negative 5 here, and here are where all the distance is closer than 5, smaller than 5. Next one. The second one, x absolute is greater than 5, means the distance of x is more than 5 from its origin point. Let's draw again our number line. And the distance that x wants is greater than 5. So it will be this side or this side. So what's our conclusion here? So if I have fx absolute less than a value, for example a, it is equivalent with negative a fx a. Meanwhile, if I have a function greater than a value of a, it is equivalent with fx greater than a or fx less than negative a. Let's put that theory into action with this example. So, don't mind the domain first. Let's try to solve it first. I have 3x minus 5 less than 13. Remember, if the symbol is less than, how do you solve it? So, it is between negative a and a. So, how to solve this? 3x minus 5 less than 13 greater than negative 13. Let's add 5, add 5, add 5. I got 3x less than 18 less than negative 8. Now divide all by 3. I'll get 6 and negative 8 over 3 here. Okay, now we will see it according to its domain. So domain of real numbers, that's I think the easiest part because we don't really think about that. 8 over 3, 6, everything is real numbers on the number line, right? And it's closed circle, it's included. So just here. But next one, the domain is positive number. Positive is greater than 0. So 0 here, because 0 is greater than 8 over 3. And then we have 6 here. And 0 is not included, so open circle. Only positive numbers. Next one, what if it's integers? So integers are the non-fraction. I think I need to make it longer. So we start with 6 and then 5, and I'm going to fast forward for you. So there you go. You see, I do not shade the number line because it's only the integers that is the solutions. So I only like make a close circle, or yeah, make 6, 5, 4, 3, 2, 1, 0, negative 1, negative 2 as the answer. Okay, I guess that's enough. Let's continue to discuss with the guided practice section.